Hi, grade 9s, and today we'll be working on the density lab together. So remember from our previous lesson, to measure density, you've got to take the mass and then you've got to divide it by the volume. So our goal today is to find the mass and volume of these bad boys and then figure out the density from there. These are called rubber stoppers, and they're made of rubber, and they're meant to stop any liquids or fumes exiting a graduated cylinder or a beaker or a test tube. So we'll be using also a graduated cylinder today, these 4 rubber stoppers of different sizes. We'll also be using an electronic scale to measure the mass of these rubber stoppers. Traditionally in science class, if you were to measure the mass of something, we would use a triple beam balance, but welcome to the year 2021, and we will be using an electronic scale today. So we're very lucky to have that. And lastly, we'll be using this. This is called an overflow can. It's just a metal cup. Nothing special about it, except there is a hole inside. So this hole has been designed so that it catches any overflow of liquid in a controlled manner. So instead of water spilling from all edges, if you were to put too much liquid inside, it would instead flow out this hole and out this spout, and you can catch it using a graduated cylinder or a beaker, whatever container that you'd like. Today we'll be using a graduated cylinder. All right. Okay, and I think that is it. So go ahead and download the handout titled Lab Density of Rubber Stoppers. On this handout, we've got the procedure, materials list, we've got the purpose. I'm going to help you with filling in some of your data today. So I'm going to help you find the mass and volume of these rubber stoppers so that you can then calculate its density on the last column. You're going to then create a graph and answer some analysis questions. All right, so let's get started. So first of all, I'm going to grab this bad boy and calculate and measure the mass of these 4 rubber stoppers. So to start off, you want to put your scale, or I want to put my scale on a flat surface. I'm going to turn it on, and I'm going to make sure that it reads 0 before I start measuring its mass. So I'm going to click the 0 button. All right. So I've got rubber stopper size 0. All right. So you're going to go ahead and put the mass of the rubber stopper size 0 once I tell you the number. So here it is. 6.8. So you're going to write 6.8 for the mass of a rubber stopper. And that's size 0. For size 2, the mass is 7.2. 7.2 grams. So go ahead and write that down in your observation chart. For rubber stopper size 4, we've got a mass of 15.1 grams. So go ahead and put that in your chart. And then for rubber stopper size 5, the mass is 16.8 grams. All right, so you should have this filled in so far. So this was the masses of the 4 rubber stoppers. Now we're going to measure the volume, and then you're going to calculate the density on your own. So how the heck do we calculate the volume of these rubber stoppers? Well, we're kind of measuring the overflow of these rubber stoppers in water. So let me show you how that works. So we're going to fill this overflow can so that it overflows. And here's how we do it. So I'm just going to pour it in, pour the water in. Oh, we're making a mess. No overflow yet, nothing's dripping out. So I'm going to add a little bit more water. Ever so slightly until I start seeing some overflow coming out. There. All right, did you guys see that drop? So that means the water level is exactly where that little hole is. So what I'm going to do is I'm going to take rubber stopper size 0, And I'm going to drop it into this overflow can, and I'm going to catch the overflow liquid in this graduated cylinder. And that will be my volume of a rubber stopper, size 0. Ready, set, go. See, it's dripping, and I'm catching the liquid in my graduated cylinder, and I'm going to measure its volume, and then whatever volume we get, we're going to record that on our chart. All right, so it is good to meant to read the volume of a graduated cylinder. You always want to make sure it's on a flat surface, and then you're going to go eye level on it and read the lines. So it is at about 8 milliliters. So it's 8 milliliters of water, but because rubber stoppers are solids, we're not going to use milliliters. We're going to use the units centimeters cubed, or centimeters to the power of 3. So that was 8 centimeters cubed for a size 0 rubber stopper. All right. So if you're here for yesterday's lesson, we talked about how 1 centimeters cubed is equivalent or equal to 1 milliliter. All right. So that's why we can kind of interchange it. I'm going to pour out my excess liquid onto this extra container that I have, this beaker. And I'm going to go ahead and drop rubber stopper size 2. Now, it doesn't matter that we kept our rubber stopper size 0 in here, because it's going to produce the same overflowed volume of water, whatever is it doesn't matter whatever is inside of it, okay? Okay, so I'm going to drop rubber stopper number 2, and I'm going to catch the overflow. All right. So again, it doesn't matter that now that there's 2 rubber stoppers in it, because we're measuring the overflow of 1 rubber stopper at a time. So yeah, so it doesn't matter. Okay, so now we've got about 9 milliliters on my graduated cylinder, so that'll be 9 centimeters cubed on your chart for size number 2. Let's take our third rubber stopper, size 4, and we're going to measure the volume of a rubber stopper size 4. Flowing, flowing. Once it stops, I'll go ahead and read it for you. All right, good enough. I've got a volume of 12 milliliters. So you're going to write 12 centimeters cubed for number 4 rubber stopper. Last one, number 5. Ready, set, go. So you can tell the bigger the rubber stopper, the more overflow you're going to get, and the bigger the volume. All right, so I've got a volume of about 14 milliliters. So I'm going to write 14 centimeters cubed on the chart. So then your chart should look like this. All right. We determined the mass of each rubber stopper using the electronic scale. We determined the volume of each rubber stopper by measuring the overflow. And you are now going to calculate the density of each rubber stopper. So don't forget from yesterday's lesson the equation to calculate density. Mass divided by volume. After that, you're going to create a graph, and you're going to answer the analysis questions, and then you are good to go. If you have any questions, feel free to ask me. Otherwise, have a wonderful day, everyone, and happy Flannel Day.